So yes, in order to solve differential equations, we will be taking the integral on both sides. But in order to be able to do that, we first have to make it look nice. Because do we want to take the integral with stuff that had two different variables in it?
No.
No. Yeah, we split our variables up. Do you remember what that's called? No. Okay, separation of variables.
Oh,
There we go. So remember that a differential equation is just an equation. With derivatives. And so our solutions are functions. Okay, we're not just going to get a number when we solve this. Okay, we're going to get a function. Alright, now in order to solve these, we want to use separation of variables. So our first step is write if for some reason I have an f prime of x or y prime, we need to rewrite that as dy dx or whatever dy dt, whatever our other variable is. Then our goal is to move all x's to one side and y's to the other. And this includes your dy and your dx. Then we want to integrate. And we will solve for y if needed. So sometimes, depending on if they ask you for the function in terms of y, if it's a multiple choice question with the answer in terms of y, then we would want to solve for y. Okay. Now, just solving for y, what type of solution do we remember? What is this going to be? If I stop here.
General?
Yeah. So this is my general solution. What's my other kind?
Particular.
Particular. What do I have to find a particular? Yeah. So if I want the particular solution, we plug in the condition. To solve for C. So we are integrating, and it's going to be an indefinite interval. So we are going to have constants. So that's why if it's a general solution, those constants will still be there. If we were running a particular solution, they will have given us a condition, and we will solve for that C instead. Alright. So the first thing that we can sometimes do with differential equations is just be given an answer. And we want to verify if something is a solution for differential equations. So in this case, it says show that both y equals 2 to the ex and y equals e to the negative 4x are valid solutions for the differential equation y double prime plus 3y prime equals 4y. Now, since I'm not actually solving this, I don't have to rewrite it as dy dx. I don't have to separate variables, things like that. I'm just verifying that the things they gave me are solutions. So they give us y's, which we have a y in our equation. What do we also have in our equation? derivative and the second derivative, right? So I need both of those. So let's just start with our 2e to the x. So if I have y equals 2e to the x, what is our first derivative? Super exciting. 2e to the x. So then what's our second derivative? Also 2e to the x. Yeah, super exciting stuff, right? But then we're just verifying. So that means that when I plug into this equation, so I have 2e to the x plus 3 times 2e to the x needs to equal 4 times 2e to the x. So 3 times 2 gives us 6. Oh, sorry. It should be e to the x. There we go. Okay, and then 4 times 2 gives us 3. So 2e to the x plus 6e to the x gives us 8e to the x. Do those two things equal each other? Yeah. So we're good to go. Yes, no, maybe. Now they will not lie to you. It will not say show that these two things are solutions, like if it's not. Now it could say, is this thing a solution? And then your answer could be no. But if it says show that they are, it's not going to give you something that doesn't work. Yes, no, maybe.
Yes.
Okay. What do we have to be careful about on our second one?
Derivative of the inside.
Yeah, we're using our chain rule. Are we all okay with that? Okay, what's our first derivative? And our second derivative?
16e to the negative 4x.
And should that still make my equation work?
Yes.
It should. So I have 16e to the negative 4x plus, so I have 3 times my first derivative, so what's that going to be?
Negative 12.
Negative 12 e to the negative 4x equals 4 times my original function is just 4e to the negative 4x. Yes. If I have 16e to the 4x minus 12e to the 4x, I do indeed get 4e to the negative 4x. So does it work as well?
Yes.
So both of these would be particular solutions. Okay, what questions do we have on that? Right, let's look at some where we're actually solving. Find the general solution for each of the following. These ones are just kind of some straightforward ones. So on my first one, I have dy dx equals 2x over y. Okay, do I already have a dy dx?
Yes.
Yeah, right, so I don't have to rewrite anything. That's nice. Then I need to separate out my variables. So I need my y's on one side, my x's on the other. Does it matter which side is what? Like which side I put the y's, which side I put the x's? No. Usually we're going to kind of go with whatever's easiest. So notice that my dx is on the bottom on the left-hand side. So I'm going to multiply both sides by dx. Yes? So that means that I'm going to be putting it on the right-hand side. Which also means that I need to multiply by a what?
A y.
A y. So I get y dy equals 2x dx. So the dy and the dx are important because those tell us what we are taking the integral with respect to. So we are taking the integral with respect to y on the left-hand side and x on the right-hand side. So what is the antiderivative of y?
Half y squared.
Equals just x squared. Yes?
Yes.
And then what do I have to have at least one of?
C.
C. Could I technically put a C on both sides? Yeah, but then if I moved all the C's to one side, is it still a C? Yeah. So we just put it on one side, but you do have to have it on one or the other. That would be a fine general solution, just for the general solution. If I will say, like, okay, notice that both my x and my y are being squared. So what type of equation is that? It's gonna be a conic section, right? Are we okay with that? So like the general solution, if this was like a multiple choice question, they're gonna tend to write that in terms of our x's and our y's being on the same side. Yes? So notice 5y squared minus x squared equals c. Yes, no, maybe? And so then the only other thing is, instead of having a fraction there, we might multiply everything by like a 2. Is this, if I multiply c by 2, is it still c? So this is actually going to be a hyperbola because we're subtracting. Now, again, for your response question, you're fine to leave it like this. Unless it said like, in terms of y, then you would need to solve for y. This one is a weird one to solve for y because you're going to end up with like a plus or minus and a square root. So usually they want to do that. More often than not, you're going to see it written in a conic section, standard form. Alright. What do we want to do with our next one? So I'm looking at B. What do I need to do with my dx?
Multiplied over
Cool. Which also means that we need to?
1 over y on the other side.
Not quite.
Or 1 over y squared.
There you go. Are we all okay with that? Now, something to be careful about. And I don't know what it is about fractions. Remember, the only time that we end up with a natural log is when I have 1 over y, or 1 over something to the first power. There's just this inclination to like want to do the natural log of y squared anytime, or the natural log of whatever's on the bottom, because you see the fraction, right? But that's not what the antiderivative of it is. That only works if it's to the first power, okay? Because technically, this is y to the negative second, right? So we just use our power rule there, okay? So we would add 1 and get
Negative 1.
negative 1, and then I'm dividing by negative 1, so I get negative 1 over y equals, well, if I don't have anything there, what do I get? Just an x, right? X, and then I also need my plus c. Yes? No limit. Again, for your response question, you're fine to leave it like that unless it says and solve for y or in terms of y. If we did that, notice that we would like flip both sides and multiply by a negative. So this would be like negative 1 over x plus c. Questions on our first two? Those are pretty straightforward. Next ones, we're getting a little bit more into it. So we have x's and y's this time. So I'm going to, again, divide by a y and multiply by an dx. This. Now, this time, y is to the first power. It's on the bottom. So what are we going to get here? This one we do get a natural log. Are we okay with that?
Yes.
Yeah, so the first power, we do end up getting not just the natural log, but the natural log of the absolute value of y. Okay, antiderivative of just x is going to give us 1/2 x squared plus c. Now, if we solve something like this for y, what are we gonna have to do?
Exponential.
Yeah, with a base of e. So we get y equals, technically it would be a plus or minus, right? Because I have an absolute value. So in order to drop my absolute value, so I would have e to the 1/2 x squared plus c. But is that how we tend to actually write it?
No.
No, because remember my exponent rules tell me that if I am adding two things in the exponent, right, I could also write that as multiplication. So I would have e to the 1/2 of x squared times e to the c. But e to the c is still just a constant. And plus or minus a constant is still just a constant. So we get c e to the 1/2 x squared. And we will find out if it's plus or minus depending on the initial condition that they give us. So just kind of remembering our excellent rules there. Alright, this is the last one. What do we have? Or what are we missing actually? Yeah, dy dx. So this is one of the ones where, what do I need to do first? I gotta change my y prime to a dy dx. Yes? Are we also okay if in that step I also add over my 3e to the x? Yeah, because it has an x and so I'm going to need 2 anyway. Okay. So then I can multiply by minus dx. So what is the antiderivative of 4y? Okay, antiderivative of 3e to the x. 3e to the x. And then I have a plus c. Now, that's not going to be a conic section. It's not going to be super nice to solve for y like we got here with an exponential. So, like, we're just going to leave our answer like that. If you have a bunch of funky stuff like natural logs of x's already or e's, things like that, you would just leave it there. Otherwise, you would get like a square root of stuff with e's in it, so we're not super worried about that. Alright, more questions? Yeah. So far, so good. Differential questions are pretty straightforward. Alright. This will be the last one we'll look at today, and then tomorrow we're going to be doing some particular solutions. So, do I have a dy dx already?
Yes.
Yeah, that's nice. So, what do I need to do?
Dx. Or just dx.
No, multiply by dx and multiply by a
3y squared.
3y squared. Okay. What's the antiderivative of 3y squared? Y cubed. What's the antiderivative of x squared? Yeah. And the antiderivative of 1. X. And then I have a plus c. Again, I have a cube. So technically this one's not too bad. If I wanted to solve for y, right, I would just take the cube root of all that stuff. That's no maybe. Questions on that?